Guys, welcome back to another Algebra 2 lesson. We're beginning the second chapter today, Module 2, and we're going to look throughout this entire chapter about graphing inequalities, graphing equations, systems of equations, absolute value equations, and systems. So this is, to me, a fun lesson. I enjoy this. Hopefully you'll find it fun too. I'm going to jump right in. Make sure you're taking down the vocabulary because there will be a vocabulary test as previously. It's important to know the vocabulary to understand what a question is asking. So we've got equation, solution, root, zero, and inequality. And as we go through this lesson, these vocabulary words will be defined in more detail. So we're going to look at applying the addition property of equality, the subtraction property of equality, multiplication property of equality, and the division property of equality. And we can summarize those by just kind of saying, whatever I do to one side of an equation, I have to do the exact same thing to the other side to keep it equivalent. That's why they're the properties of equality. If I multiply one side, it'd be like throwing weights. If I had a set of scales, if I throw double the amount of weight on this side, then I'm going to have to double the amount on this side. If I take 2 pounds off of this side, then to keep my set of scales balanced, we know I'm going to have to take 2 pounds off of this side of my scale. So that's all that we're doing when we're solving equations, is keeping this imaginary set of scales that's separated by an equal sign. We've got to keep those things balanced and equal. And we do that by applying the properties of equality. So let's look at this original equation we're given here. We can see that we're going to have to apply the distributive property here in order to simplify and solve. So let's go ahead and get started. 1/3 times 2 is 2/3. 1/3 of negative 57 is negative 19. 1/3 of 6 is 2. And 1/3 times negative x is negative 1/3 x. So all that we've done so far is distributed. Now we can combine our like terms. This negative 2/3 and this negative 1/3 x are both x's. They both have x's in them. And the negative 19 and the positive 2 are both constants. So we can add the constants together and we can add the x terms together, giving me 1/3 and negative 17 equals negative 4. At this point, we want to get rid of this negative 17. Remember, the goal is always to isolate the variable, to get that variable all by itself on one side of the equal sign. So if I'm trying to get this x all by itself, I can see that I can easily get rid of minus 17. How do I get rid of a minus 17? Well, I add 17. If I have minus 17 plus 17, that's going to be 0. But remember, the property of equality says if I add 17 on this side to get that to be 0, I've got to do the same thing on this side or else my scales will no longer be balanced. So I add 17 over here. I have to add 17 over here. Now we can simplify, and I have 1/3 x equals 13. Again, the goal is to get this x all by itself. If you remember back to Algebra 1, we get rid of a fraction by multiplying by its reciprocal. We take that 1/3, we flip it over, and we multiply by 3/1. And the reason that we do that is because if I have 3/1 times 1/3, 3/1 times 1/3, I end up with 3/3. Well, we know that 3/3 is the same as a positive 1. So 3/3 is 1. So now I'm just left with 1x equals 13 times, we've got to multiply it by 3/1 as well. So 13 times 3 is 39. So I have 1x equals 39. Well, we know that 1x is just the same as x all by itself. 1 times anything is just that anything. So x equals 39. And that is my simplified, that's me solving for x, solving my equation. There it is. We multiply by 3/1, or just 3. We get x equals 39. Now at this point, if we are wanting to make sure our answer is correct, we can plug it back in and check, and we will then see that once we plug in 39 for x, all of this on this side will simplify to negative 4. So we have negative 4 equals negative 4, and it is correct. All right, moving on. Here it has the check. It works it out for you. It came out. It works out. Woohoo, that's a good thing, right? So we can always check and know. It's the nice thing about solving equations. You immediately know if you got it right or wrong when you plug it back in. So really, there's no reason why you should ever miss these on a test because you can know the correct answer. You can know if you got it right or wrong when you turn it in. Space. The diameter of the Earth is 828 kilometers, less than twice the diameter of Mars. It's a little confusing. Earth is 828 less than twice the diameter of Mars. So we need to know what Mars diameter is, times it by 2, then subtract 828 from that, and that will tell us Earth's diameter. Well, we already know Earth's diameter is 12,756 kilometers. So what is the diameter of Mars? So let's write this out. First, we're going to complete the table to write an equation that represents this situation. It says let m equal, what are we looking for? Well, we're looking for the diameter of Mars. It gives us the diameter of Earth. So we're going to let m equal the diameter of Mars. It says the diameter of Earth is 828 less than twice the diameter of Mars. So my equation then is going to be, let's see here, the diameter of Earth. What is the diameter of Earth? 12,756 is equal to, we know is means equal to, 828 less than twice Mars. So 2 times Mars. Then we subtract from that the 828 because it's 828 less than twice the amount of Mars diameter. So we can check this. And voila, it is correct. I never know where to put myself. I never have a good spot. Maybe I should just not put me on the recording, but I just feel like it's so bland when you can't see some interaction. And I can't with my hands so much. So entertaining, right? No, not really. All right, so now we can solve it and check and see. So we add that 828. Notice it's minus 828. So to undo that subtraction, we use addition. We add 828. The property of equality says if I do it to this side, I have to do it to this side to keep that set of scales balanced. So I add 828 over here. Well, the nice thing is this becomes 0, so now I'm left with 2m. I've almost got that m isolated. I've almost got it all by itself. Well, what's happening to m? It's being multiplied by 2. So to undo multiplication, I'm going to use division and divide both sides by 2. And m is equal to 6,792. That is the diameter of Mars. And then we can stop and think about it. Does that make sense? Looking at the picture that Earth is 12,756 and that Mars would be 6,792. Kind of looks like it. You can see that Mars is smaller. And it makes sense because it says here that the diameter of Earth is 828 kilometers less than twice the diameter of Mars. So it should be about a little less than 2 times bigger, right? And it is. 800 or 6,792 is a little less than twice. It's 828 less than twice this amount, or 12,000. Let me say this one more time. 12,756 is 828 less than twice Mars diameter. So it worked out. That makes sense. It's a reasonable answer. Example 3, moving right along. We're solving again for a variable. We've got the perimeter formula of a parallelogram, and it is 2 times A plus 2 times B. Remember, perimeter is just adding all the outside edges together. And since it's a parallelogram, we know that these 2 sides are the same and these 2 sides are the same. Hence, they say 2 times A plus 2 times B. Okay, but we're wanting to solve it for B. We want to get B all by itself. So for some reason, this always throws people off because there's just too many numbers and too many letters in here. I'm going to pause this because I'm going to pull up my marker real quick. Hold on. Okay, so I've got my little marker pulled up here. But remember, this is no different than everything we've been doing before. The only difference is there's more letters in there, but we're still going to work it the exact same way as if this A were a number. Pretend it's a number. Pretend P is a number. It doesn't matter. We're still going to solve it the exact same way. But remember, the goal here is to isolate the B. We want this B all by itself. So to get B by itself, we first have to get rid of this term over here. We first have to get rid of the 2a. Well, how do I get rid of a positive 2a? Just pretend it was like 21 instead of 2a. Pretend it's 21. How would I get rid of 21? I would subtract 21. So the same thing is the same process, even though there's a variable thrown in there. To get rid of this 2a, I subtract 2a because 2a take away 2a is 0. So if I do it to this side of the equal sign, remember, we've got to keep our scales balanced, so I have to come over here and do it on this side as well. I have to subtract 2a. The only difference between this and the previous problems is I can't simplify this because they're not like terms. So actually, it should be easier. There's less work to do. We just write it and we don't have to simplify. So now I have p minus 2a equals 2b. Okay, so now remember, the goal is still to isolate the b. I've got to get b all by itself. There's a gnat in here. So to get b by itself, I divide by 2. It's being multiplied by 2. To undo that, I use the inverse operation. I divide by 2 because 2 divided by 2 is 1, leaving me with just b. But again, property of equality says if I do it on this side, to keep that set of scales balanced, I've got to do it over here on this side. So I divide this side over here by 2. Again, p divided by 2, I can't simplify that. But 2 over 2, we realize we can simplify just like we did here, and I end up with p over 2 minus a equals b. So don't overanalyze. Just because there's more letters in there, don't make it more difficult than it has to be. Just do it exactly the same way you would if they were numbers instead of letters. All right, let's keep on moving. Next problem. We're going to look at solving linear equations by graphing. I think this is fun. I know a lot of people think, oh, graphing, but there's so much that you can learn by looking at a graph. You've heard the statement before that a picture's worth 1,000 words. This graph is a wealth of information. Immediately, I know the y-intercept. I know the x-intercept. I can calculate the slope looking at this graph. There's so many things that I can determine just quickly looking at a graph. So it says the solution of an equation is called a root. So there's a vocabulary word. The solution of an equation is called a root. You can find the root of an equation by examining the graph of its related function. A related function is found by solving the equation for 0, then replacing 0 with f of x. So let's look at it. The values for which f of x equals 0 are called roots. We're looking for when is y 0. Well, we can tell by looking at the graph that y is 0 when x is negative 2. So the 0 function is the x-intercept. It's where the line crosses the x-axis. The solution and root of a linear equation are the same as the 0 and the x-intercept of its related function. So looking at this equation, 2x plus 13 equals 9. Well, I can see that they subtracted 9 from both sides and got 2x equals 4 so that they could graph it. So my slope is up 2 over 1, up 2 over 1. I can see the y-intercept is 4. 1, 2, 3, 4. My graph and my equation are matching. This is good. So negative 2 is the solution of this equation right here. Negative 2 is the root of this situation. So it's the 0, it's the root, it's the solution, it's the x-intercept. All of those things are true for this given equation. Okay, moving right along. Example number 4. Solve 1/2 x minus 11 equals negative 8 by graphing. So remember, we want to get a 0 over here, right? We want this y to be 0. So we move 8 over to the other side. Negative 8 plus 8 gives me 0 on this side. Negative 11 plus 8 gives me a negative 3. So now I have 1/2 x minus 3 equals 0. I'm right here. So what we can do now is replace that 0 with f of x, and we can graph it. So now I have an equation, f of x equals 1/2 x minus 3. So what's my y-intercept? My constant is my y-intercept. So I'm going to come over here and I'm going to put a point on -3. And my slope tells me to go up 1, rise over run, up 1 over 2. So I can go up 1 over 2. Or there's a possibility that I might want to move the other way. Instead of going up 1 over 2 this way, I could also go down 1 and over 2 this way. And that's still going to give me a positive slope because it's a double negative. Let me say that one more time. A double negative is the same as a positive, right? I go down 1, -1, to the left 2, that's -2, -1 over -2 is still a positive 1/2. So I've got my line or my points, so now I can connect them with a line, and boom, there is my graph. So remember, what we're looking for is where it crosses the x-axis. When y is 0, what is the value of x? Well, it looks like it's 6. So my solution up here for this original equation, when I had a 0 here, should be 6. Let's think about it. What's half of 6? Half of 6 is 3. 3 take away 3 is 0. So that is true. That is a correct statement. So my x-intercept is 6. So therefore my solution is 6. Very nice. Moving on. Example number 5. Tower race. The Empire State Building run-up is a race in which athletes run up the building's 1,576 stairs. In 2003, Paul Craig set the record for the fastest time running up an average of about 165 stairs per minute. The function c equals 1,576 minus 165m represents the number of steps Craig had left to climb c after m minutes. Find the 0 of the function and interpret its meaning in the context of the situation. Okay, so I just read that whole problem, and I'm going to be real honest with you. I have no idea what I just read, because as soon as I saw tower race and running up, I thought of the 5K that my sister-in-law is sponsoring or hosting, or I guess she's not sponsoring it, she's hosting it. It's going on this month, and it's about breast cancer, raising money for breast cancer awareness. The group that she's going to donate the money to is a group that makes pillows for women who have a mastectomy, and it helps them. They hold that pillow, and it helps provide them comfort, and it's more comfortable for them after they've undergone that surgery. And they make them shirts that button up and hold. When you have a mastectomy, you have to have drain tubes. It's probably more information than you wanted to know, but it is October, Breast Cancer Awareness Month, so my job is to educate. So I'm going to throw this plug in there while I'm thinking about it. So anyway, go to tristateracer.com and look that up and see if you're interested in joining this 5K to raise money for women who have had a mastectomy. So anyway, back to the problem at hand here that I'm like the little dog on Up. You know, he's like, squirrel, squirrel. That's me. Like, I read tower race, running. I'm like, oh, race, breast cancer awareness, October. Oh. So anyway, back to the task at hand here. Let me reread this problem. I'm going to pause it because you don't want to hear it again. Okay, so we're looking for the x-intercept to determine how fast it was that this gentleman ran the race. So if we look down here, it looks like the x-intercept is at about 10, or somewhere in between 9 and 10. I'm going to guess that's more like 9.5. So the graph appears to intersect the x-axis at about 9.5. So what that means is that Paul Craig finished the race in about 9.5 minutes. Or what we can say is he finished this race in so many minutes and so many seconds. So how much would that be? 9 minutes and 30 seconds would be 9.5 minutes. Okay, so now it says use the equation, substitute 0 for c, and solve algebraically to check. So we're going to plug in a 0. We're going to solve it. So first I'm going to subtract the, let's see here. I'm going to move the 165, the negative 165 to the other side. So then I don't have a negative there. I can deal with positives. So I add 165 to both sides of my equation, giving me 165m equals 1,576. We see that to get m by itself, I needed to divide both sides by 165. And I get roughly 9.55. So the solution is it's roughly 9.55. So Paul Craig completed the Empire State Building run-up in about 9.55 minutes, or 9 minutes, and how many seconds would that be? Well, this is half, 0.55 of an hour. So let's think about that for a second. 0.55 over 100 is equal to x over 60, basically, is what we're trying to think about. So if we wanted to calculate that, 0.55 over 100 equals x over 60. I'm going to cross multiply. I don't know if you can see this or if it's backwards, I never know. But we can cross multiply and divide to figure this out.